Okay, the question says that a horizontal jet will slow down and spread out as it moves away from the orifice. So there's fluid coming out of here, and as it moves out in this X direction, it's slowing down and spreading out as it moves in this direction. Assuming that the jet is symmetric about the x-axis, so that means that it's keeping on going in this direction the same on both sides, and that the central region of the jet fits the velocity profile, u equal to 1 over x minus 4y squared over x meters per second. So that's giving me the u velocity as a function of location. What is the velocity in the y direction in that region? State all assumptions, as usual. Well, the first assumption we can always get away with in this course is that the flow is incompressible. If the flow is incompressible, then incompressible continuity applies. Du dx plus dv dy plus dw dz equals 0. If we assume 2d, thus w equals 0, nothing interesting is happening in the z direction, then du dx plus dv dy equals 0. Or dv dy must equal negative du dx. Taking the derivative of u with respect to x, derivative of 1 over x, that's x to the minus 1, so that's negative x to the minus 2. And negative 4y squared over x, derivative with respect to x, same negative x squared term showing up, so plus 4y squared over x squared. And if that's dv dy, then we can integrate once to get v. V equal to integrate this with respect to y. There's no y term there, so that'll be negative x to the minus 2 times y. This one integrated in y, there's a y squared here, so that's going to become a y cubed term, and there'll be a 1/3 on the bottom, so plus 4/3 y cubed over x squared. So that's the velocity in the y direction in the region. Oops, and when we integrate, plus a constant. Now, if it's symmetric, then v equals 0 at y equals 0. There's no velocity going this way or that way on the center line. And thus the constant is equal to 0. So that v will be equal to 0 where y is equal to 0. So v is equal to negative y plus 4/3 y cubed all over x squared is the expression for the vertical component.